Welcome to another unit in the ISM exercise set Business Mathematics, this time with a unit on Extrema. Let's take a look at the exercise. Here it is: calculate all possible extrema of the following function with regards to the parameter a. Test whether they are minima, maxima or saddle points. Then that's our function f of x and y. Okay, if we're going to do this, first off, we copy the function and then we need the first and second derivatives. For the first derivatives, we just divide this here by parts containing x, parts containing y, and first get a partial derivative for x and later for y. So with regards to x, the only important parts are the x squared plus 5ax and minus xy. So here we get as a first part, as a derivative, 2x plus 5a minus y, because the y in this context acts like some kind of constant. Then, with regards to y, only the part of minus y squared minus xy. Only these two matter. So here the derivative is minus 2y minus x. And it looks like this. Okay, so far so good. This was the first derivatives. Then for the second one, again, we only considered the parts where there is x or y's correspondingly. So here, if we take or consider the first column with regards to x, so the first part, there's only 2x, derived for x, it's 2. And then the second one, we only have minus x, so the derivative here is minus 1. So we have 2 minus 1. Then we switch to y. With y, in the first part we only have minus y, so the derivative here is minus 1. And in the second part we have minus 2y, so the derivative here is minus 2. And it looks as follows. First column being the derivatives with regards to x, second column being the derivatives with regards to y. Okay, so far for our preparatory work. Then, to actually find our extrema, we need to equalize the first derivatives with 0. This gives us, for the first derivative, here 2x plus 5a minus y, which we can easily solve for y, reading as y being equal to 2x plus 5a. Something similar we're doing with the second one. Here we can solve this for x, giving us an x being equal to minus 2y. Then we can just insert the second one in the first one. So instead of x in the first equation, we insert minus 2y. This will then read as y being equal to minus 4y plus 5a. Then on both sides, we go with add 4y, so that on the right side, the 4y get erased. We get 5y being equal to 5a. Dividing by 5, this gives us y is equal to a. This then is inserted into the second equation and delivers us an x of minus 2a. So we have our possible extremum at minus 2a. Then we only need to check whether this is maximum, minimum or saddle point. And for this, we are inserting this possible extremum into our Hesse matrix. A possible extremum for any a, we insert this into the Hesse matrix. And well, the Hesse matrix only has fixed values, so it won't change. And well, what we can see here, the derivative twice for x is positive, but the determinant of this Hesse matrix, so meaning 2 times minus 2 minus minus 1 times minus 1, is here minus 3, so it's negative. And if we have this combination, so in the upper left a positive value, but the determinant being negative, this is an indicator that we have a saddle point. So we can summarize that our function has at minus 2a, a, always a saddle point independent of any value of a. So a can be any real value. Our function will always have a saddle point at a. And well, this was everything which needed to be done in the course of this exercise and concludes this exercise. And I hope you enjoyed listening to it. And if you're looking for more of the type of exercises, feel free to visit the rest of the exercise set or take a look at the corresponding playlist. I say goodbye and see you.